Hi, I'm Janet Uy, the Autonomous Vehicle Solution Lead here at Keysight Technologies, and I'd like to welcome you to the Automotive Test Event of the Year. Today, we're going to unveil to you something truly revolutionary, a new solution that will forever change the way you test automotive radar sensors and train the autonomous driving algorithms. Automotive radar is a key technology for enabling advanced driver assistance systems or ADAS features such as blind spot detection and automatic braking system. Testing the radar is critical to training autonomous driving algorithms. These algorithms use the data acquired by a vehicle's radar sensors to make decisions about how the vehicle should respond in any given driving situation. When those algorithms aren't properly trained, they can make unexpected decisions that undermine driver, passenger, or even pedestrian safety. We at Keysight understand that automotive safety matters, and that is why we set out to create a radar sensor test solution that overcomes the challenges of conventional solutions while delivering a level of performance that is unmatched in the industry today. Current solutions have a very limited field of view and can't resolve objects at distances less than 4 meters. Plus, they can only test radar sensors against the limited number of objects and not against the complexity of real-world driving scenarios. Today, with the launch of our new solution, that changes. But first, let's hear it from our Keysight executive, Yi Hui Sin. Take it away, Hui Sin.
Thank you, Janet. And hello, everyone. I'm Yi Hui Sin, President of Keysight's Electronic Industrial Solutions Group. To help customers turn their vision into reality, we often need to solve new measurement challenges. Testing autonomous driving algorithms presents that exact challenge. Automotive designers need to test complex radar scenes that are difficult to create repeatedly on the test track. And they need to test faster and sooner. Today, I'm proud to introduce to you the Radar Scene Emulator. This is a huge step forward, providing a new way to emulate complex radar scenes for training autonomous vehicles algorithms in a lab. We are delivering a much-needed realistic bridge between simulation and road testing. And this is the first of its kind. With unmatched performance, our Radar Scene Emulator provides a clear path for automotive companies in their next steps towards vehicle autonomy. We are delivering the performance, accuracy, and reliability that our customers demand to fulfill mission-critical safety requirements. I'm excited for this new launch, and together with the automotive ecosystem, we are solving tough challenges and enabling innovations for autonomous driving and electric vehicles. And we are just getting started. Thanks, and back to you, Janet.
Thank you, Hui Sin. Keysight's new Radar Scene Emulator is a game-changing solution. It allows automotive OEMs to emulate real-world driving scenes in the lab, covering common to corner cases. But the ability to test real-world complexity is just one of the Radar Scene Emulator's key benefits. It also helps radar sensors see more with a wider contiguous field of view and support for both near and far targets. This eliminates the gaps in a radar's vision and enables better training of algorithms to detect and differentiate multiple objects in dense, complex scenes. As a result, autonomous vehicle decisions can be made based on the complete picture and not just what the test equipment sees. Finally, the Radar Scene Emulator helps accelerate algorithm learning by providing a deterministic real-world environment for lab testing of complex scenes that today can only be tested on the road, if at all. You can test scenarios earlier with complex repeatable scenes, high density of objects, environmental characteristics, or any mix of these while eliminating inefficiencies from manual or robotic automation. So, let's now learn a bit more about what this solution does and take a closer look at the technology innovations behind it.
Automotive radar is forever changing how we design, tune, and train autonomous driving algorithms. With millimeter wave radar, your algorithms will see more at higher resolution and at closer distances, assuming you can train them with complex scenes taken from the real world. The top vehicle's algorithm has been trained with full scenes. The bottom vehicle's algorithm only saw an incomplete view of the world. It's clear which vehicle is the safest. Modeling complex radar scenes in your lab with the ability to replicate and retest corner cases is the only way to accurately train an algorithm. The ability to model beyond tens of radar objects to hundreds is a game changer. Automotive companies understand how complex it is to test autonomous driving algorithms and the safety issues at stake. Testing requires replicating complex, repeatable scenes in a lab environment. The more accurate the scenes, the faster your algorithms can be trained. That's where current in-lab solutions fall short. They often require manual or robotic automation, meaning testing takes longer, and they generally support just 4 to 8 objects. So, how many objects is enough when modeling a scene? Is 10 enough? Or 20? Maybe 30? How about 100? Considering what's at stake, we at Keysight felt 500 was more in line with the exceptional resolution required. We also worried about how close to a car's bumper we should model objects. 8 meters was much too far. 4 meters is better, but still adds a big risk of a blind spot in front of the car's bumper. Putting safety first, we designed our radar test solution to operate at 1.5 meters. Keysight's new Radar Scene Emulator, or RSE, sets the new industry standard. It's a revolutionary step forward for autonomous driving developers who value safety first. The RSE provides full scene emulation of up to 512 objects at distances as close as 1.5 meters from the vehicle. Delivering this revolutionary radar scene emulator required 2 key breakthroughs. First, Keysight developed a proprietary miniature radar target simulator, each with its own antenna. Second, we integrated 8 of those mini radar target simulators onto one circuit board and arranged 64 boards in a semicircular array. The result? 512 individually controllable, high-precision objects that form a virtual wide screen for rendering real-world driving scenes, all integrated into a benchtop anechoic chamber. The RSE can be paired with any third-party simulation software to render those 512 objects into complete scenes on the wide screen. To bring this solution to life, Keysight partnered with IPG, an industry leader in scene generation software. Keysight's new Radar Scene Emulator is a world-class solution, capable of recreating complex and corner case scenes, environmental characteristics, distance, speed, interference effects, and more.
Hopefully, you now have a better understanding of what the Radar Scene Emulator is, what it does, and how it works. This solution is part of Keysight's Autonomous Drive Emulation Platform, which is an open platform that emulates synchronized connections to all relevant in-car sensors. Together, Keysight's Radar Scene Emulator and the Autonomous Drive Emulation Platform offer the ideal solution to help you realize new ADAS functionality on your path to the next generation vehicle autonomy. Now let's hear it from Thomas, who is a project lead in ADAS testing at Renault.
Okay, I'm Thomas Guérino. I work at Renault on the testing department, and my role is to find method and tools to validate AD and ADAS function. We started to discuss with you with Keysight in 2018, and at this time we looked for tools to stimulate radar for AD and ADAS Edge High Health System badge. We can sum up in 3 words. The first is innovative solution, second word is flexibility, and the last is a very good relationship between teams. Do not change your mindsets. Keep pushing on innovation and keep this good relationship with your customers to find solutions specially dedicated for customers.
Now that we've heard from Renault, let's go behind the scenes with some of the actual engineers who put their blood, sweat and tears into bringing our new radar scene emulator solution to life.
I spent the last 15 months or so as part of the team that's breathing life into this new technology, the radar scene emulator. In the 20 years that I've worked in and around test equipment, I can honestly say that this has been one of the most unique and challenging projects that I've ever been a part of.
Autonomous driving is a future capability that can offer enormous quality of life improvements to those who cannot drive themselves. My father was diagnosed with multiple sclerosis, and it's been difficult to watch the man who helped me with my math homework, taught me how to play softball, struggle as his physical ability declines over the years. Some days are better than others, but he often needs my mother to drive him to the store or to the doctor. And I know that this loss of independence is difficult for him sometimes. Autonomous driving would allow people like my father to hold on to their independence while still being safe on the road.
I have 3 kids who will grow up with self-driving cars. It brings me satisfaction to know that I had a small part in indirectly keeping them safer by enabling more comprehensive testing of ADAS and AV technologies.
This project had some interesting requirements. The most difficult requirement related to squinting the antenna beam in an unconventional way while trying to keep 40 dB transmit-receive isolation and above 20 dBc side lobe levels. Being new, I immediately researched what has been done before instead of recreating the wheel, and I found a lot of literature and research on how to remove the antenna squint or even squint in a certain direction, but there was zero literature on what I wanted to do. This took a lot of trips to the drawing board. Pure determination and confidence from my colleagues saw me through to success.
We also have product planning, product marketing, customer support, R&D researchers, etc. from US, Europe, and Asia. I really need to stay late at night and sometimes very early morning to engage and align well with all my project partners. However, what really keeps me awake at night is when the design doesn't work, system fail, or when you have challenges to get the materials on time.
The radar scene emulator is like virtual reality goggles for radar sensors in cars. Pretty cool, huh? The excitement within the research team in Keysight is just very palpable. They were energized by the challenge posed in developing this solution and now are super excited by the possibilities this solution will enable, accelerating, autonomous vehicle development and its several benefits to society. I look forward to that day in great anticipation.
Watching 1 or 2 pixels emulate a scene is one thing my brain can still follow and match the interactions of 1 or 2 targets, but seeing the environment with hundreds of targets is something else. It's a cluttered world, and it's going to take a lot of innovation in many disciplines to make sense of it.
It's been exciting working on this project because the science behind radars and sensor fusion is just fascinating in general. It is also fulfilling to be involved in a solution that will be making autonomous driving safer in the future. And this solution is also more environmentally friendly than having to do hundreds of miles of drive tests out on the road to train and verify the radar's algorithms. The complexity of the system introduces a lot of challenges related to calibration and software and hardware integration. But it's great to be working on those challenges in a team and a company that has the expertise to solve these challenges.
artificial intelligence community tells us that autonomous driving will be safer than human driving, but how will we know? We'll contrast the following closely related scenarios. A child dashes out into the street to fetch his or her ball versus the ball bouncing out into the street, but the child remaining on the sidewalk. It's my hope that our system can present to the radars these sorts of scenarios and others as the radars would see them in reality, and then it's up to the car's AI to learn to react to the sensor information in the safest manner possible, case by case. And only then will the general public, and for that matter, the car companies themselves, gain confidence in this technology.
I'd say my goal for all this work is to see our technology widely adopted in the autonomous vehicle industry, and to know that it's making a difference for the engineers who are making autonomous vehicles a reality.
The end goal for me in this system is that the self-driving systems are sufficiently safe that I can think about putting a grandmother or a relative that shouldn't be driving out in that driverless taxi.
The amount of innovation coming from everyone working on the RSC is truly impressive. We've come a long way since the early days, when a consistent theme emerged. Condensing the story, it goes something like this. The idea was presented to the Keysight Labs engineering team, and they said, I don't know, we've never done that before. And then we talked to the software team that has had to develop the code and interface to the hardware. They said, I don't know, we've never done that before. Next came the production team, the people who build and determine how we will ship this unit to you. They said, I don't know, we've never done that before. But now we've figured out all those crucial details, and every department outdid what has ever been done before. The RF hardware team submitted multiple patents. The software team in Germany developed the code to hold it together. And the production team will be ramped up to build these units as soon as you place an order. As you have seen and heard, this new solution makes it possible to perform in-lab testing and training of the algorithms that interpret radar echoes and make crucial driving decisions. The RF transceiver that has been made small enough to fit into a chip-sized unit. We put 8 of those on a board and then stack multiple boards next to each other. And as we work to describe the technology, to produce the videos that you're watching, to write white papers, a press release, a data sheet, some web pages, we keep stumbling on what to call this new, small RF front end. The men and women that designed it say each one is like a pixel in a TV screen. In similar fashion, they're assembled into a larger image. And that's what the Scene Emulator is designed to do. So each element is a pixel, or a radar pixel, or maybe it's a rixel. To introduce revolutionary technology, we need revolutionary words.
At Keysight, we're inspired by the passion and dedication that each of our engineers put into designing and developing the Radar Scene Emulator. What they have accomplished with this industry-first solution and all of the technical challenges they had to overcome to bring it to market is nothing short of amazing. Now let's hear a few words from Tom Gotzel, who leads our automotive business here at Keysight Technologies.
Hello, my name is Tom Gotzel and I'm the Vice President and General Manager for the Automotive and Energy Solutions business at Keysight. Over the last 6 months, we have shared with you how we've advanced the state of our breakthrough radar scene emulation technology to support first 20 and then 50 targets. Today, with the introduction of our new solution, we have cleared the path to full scene emulation with support for 512 targets, enabling customers to test complex scenes that were previously only possible on the road. Our innovative miniaturized radar target simulators, which are central to the new radar scene emulator, expand the field of view for the radar sensor under test to ± 70 degrees and greatly reduce radar blind spots associated with conventional approaches. Backed by over 23+ patents and Keysight's rich history in bringing technological innovations to market, the Radar Scene Emulator is just one way we're working to address automotive OEM challenges on the path to the next generation of vehicle autonomy.
Developing autonomous driving algorithms is complex because there are a lot of variables involved. Your emulation system should not be one of them. No autonomous driving developer should settle for anything less than the most precise, highest resolution emulator on the market. Keysight's Radar Scene Emulator accurately places up to 512 objects as close as 1.5 meters to as far as your radar can see. This level of performance is unmatched in the industry today. When automotive safety is what matters most, trust Keysight to help you realize your vision of complete vehicle autonomy.
Thanks to all of you for attending the launch of our new Radar Scene Emulator. If you'd like to dig deeper into the technology behind our new Radar Scene Emulator, or just want more information about the solution, be sure to check out keysight.com/find/discover RSE. And now, I'd like to turn things over to one of our automotive experts who will facilitate a Q&A session to address any questions you may have. Take it away.